Okay, gentlemen, Unit 710, last one of the unit. Scientific notation. And guys, we talked about this in 7th grade, obviously, and the idea behind scientific notation is that we take big numbers and we write them smaller using exponents. They make them easier to work with. Okay. Now we're gonna see a couple of terms here. We're going to see things like decimal form or standard form. That's the way we're used to seeing numbers, even if they're huge or very small. Okay? So if you see decimal form or standard form, they're asking you to put it back into a form that you're used to seeing. Okay? Sometimes they're going to give us that form, the form we're used to seeing, decimal form, and they're going to ask us to change it to scientific notation. Okay? Now, looking at this first thing, this represents a number, right? It's one term. It says rewrite the number in decimal form. It says the mass of an atom of helium is 6.65 times 10 to the negative 24th. So it's a tiny, minuscule measurement. Okay, and because it's so small, rather than having to write things with 24 places behind the decimal point, okay, we change it to scientific notation. It makes it easier to work with. All right. Because we may have a lot of these atoms. We want to know what the mass of a lot of these atoms are, and we'd be multiplying the two things. And rather than multiplying these numbers in standard form, we'd multiply them in scientific notation. But let's just look at this. It says mass of an atom of helium is 6.65 times 10 to the negative 24. They want us to rewrite that in decimal form. Let me ask you something. Is this a big number or is this a small number, Miles? It's a very tiny number. So we can always use that to help us decide which way to move the decimal point. So I'm starting with 6.65, right? That's where I'm starting. But I know this needs to be a very small number, Ruben. So which way do I need to move the decimal point? Do I need it going left or do I need it going right? If I move it left, that's going to make it smaller, isn't it? And how many places do I need to move it left, Ruben? 24, because I'm using the exponent of the power of 10. Okay, so 1, 2, 3, 4, 5. There's no way I'm going to make all those. I'm going to have to make this super tiny. Let me move this over because I can. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4. Decimal point. 0 out there. And I'm going to put zeros in all of these places. It's going to be 23 zeros, guys, because remember the decimal point is always behind one number, right? In this case, it was behind the 6. Okay, so I add 23 zeros. Tiny, tiny, tiny little number. Okay, but think about this. Think about this. The way we could write this, this is 6.65 over 10 to the 24th, right? Because that's a negative exponent. We're moving it to the bottom of the fraction. Okay? So 6.65 divided by 10 to the 24th. 10 to the 24th is a huge number. So when I divide 6.65 by that, it's get a very small number. Okay? So the answer is that. 0 point and then 23 other zeros, 665. Okay? Very small. Yeah, Jumbo. I'm sorry, multiplying it by 10? 10 to the negative 24th. Do you agree that this is 6.65 times 1 over 10 to the 24th? Right? And then if I multiply that, I get 6.65 over 10 to the 24th, right? But you want to get the decimals? You want to get rid of the decimal? So if I move this 2 places, right? Well, I'm getting rid of the decimal. Up. No, that's multiplied by 1 over 10. 1 over 10 squared, 10 cubed, 10 to the 4th. Right? Do I need to keep going? How many times is it going to move? 24 times. Okay, guys. Good job. See you at the next example.